In this video, we're going to examine the side-side angle case of the law of sines. In order to help us understand why there are multiple possible scenarios, we're going to use GeoGebra's visualization capabilities. So here we have given angle A, the side adjacent to it, which we're going to refer to as C, the ray adjacent to it, which is an unknown amount, but the angle is fixed. However, C is a fixed length, and the side opposite the known angle, which we refer to as side little a, is a fixed amount. In other words, we have side-side angle. Now here you can see side A is a fixed amount, and I can move it back and forth. And if we're given a length of 8.5 for side A, given an angle measurement of 37 degrees for angle A, and a side length of C of 18, you'll notice that there's no possible way that that is going to ever form a triangle. So to help us see why that's the case, let's drop the height, the shortest distance from point B down to the ray opposite it that makes up angle A. You can see that because of the fact that side A was less than the height amount, that there's no possible triangle that we can make from those dimensions. So let's go ahead and adjust the side opposite our known angle amount. So I'm going to make it a little bit bigger. So let's say in this case I make it 10.8, which is exactly equal to our height amount. Well, in this case, if the side opposite our known angle is equal to the height amount, there's one triangle possible, and that triangle ends up being a right triangle. In other words, that length was just right in order for it, as we to swing that point C along all possible locations with a distance of 10.8 away. There's only one place it can hit the ray in blue. So now if I make it a little bit longer, if you notice there are two locations where that's possible. Yes way, there are actually two triangles possible. There's a triangle at that location, which we're going to refer to as C1, and if you swing it over farther past that, there's also a location over here, that purple triangle that is created. So in this case, side A was greater than our height. However, it was less than side C adjacent to our known angle. So there's one of our triangles, and there's our other triangle that was possible with that angle amount, and that side combination. Now, let's go ahead and make side A a little bit longer. Once again. So we'll go ahead and we'll adjust it. So this time, let's go ahead and make it larger, and let's actually make it larger than side C, and let's see what happens. As we swing it over, it actually misses that second point of intersection, as in the last case. But as you'll notice, it does hit in one intersection place. So as C swings through its arc of the circle, there was one location where point C hits that blue dotted ray, forming the one triangle right there. However, if we continue swinging through, it misses it as it swings over on the other side. So hence, if side A, the side opposite our known angle, was larger than side C, then it's only going to be one triangle possible. And here's a little bit more of an extreme case. Now, be careful in terms of the lettering here. In terms of A and C, we're really talking about side opposite known angle and adjacent side to known angle. So let's go ahead and once again, what we're going to do is let's summarize what the different possible scenarios are. So in summary, given side-side angle, where A is the side opposite the given angle A and C is the other given side, if A is less than the height, little a is less than the height, then it's too short. No triangle's possible. But if side A is equal to the height, then it's just right. Literally, it's just right. And you will have one right triangle that can be formed. However, if A is bigger than our height value, but less than side C, then there are going to be two triangles that are possible, that orange triangle and the purple triangle shown. And finally, the last possible case is if A was greater than side C, then as it swings through, it'll intersect the blue ray one time, creating one triangle possible. But as it swings toward the other side, it's going to miss on the other end. So there's only going to be one possible triangle. So there's an example. As it swings through, it hits, but then it misses over on the other side. So this is our summary. Once again, there are multiple things that could potentially happen, but the biggest takeaway should be draw a picture and figure out the height value so you have a sense of what seems like a reasonable solution before you start plugging numbers in to formulas. All right, so that you have a sense of, does it seem reasonable that there should be one triangle possible? Does it make sense that a right triangle is the right solution? Or should there be multiple triangles possible? In the follow-up video, I'll go about showing you how to make the calculations to find the missing sides and angles for both possible triangles in the two triangles possible scenario.